Welcome. In this lesson, we're going to show you how comments work, and we're going to show you how data types work. How we can introduce some variables into our code. And we're going to do that with the S.O.S project, which is we're going to get a single LED to act like it's some sort of distress signal we're going to be sending, and we're going to have the LED go dot 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 dash 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 dot dot dot. So the dashes need to be longer. We need to see them longer, and then the dots are going to be the LED is going to go on very quickly. So that's the build, and when we're doing the code, I'll show you these new things I want to introduce to you. So let's switch and show you how to wire everything up. We need our Arduino, we need our breadboard, and in this build, we're going to use an LED and a resistor, and the resistor needs to be between 330 you have available in your kits, or around 220. Now if you're like me, I've probably may not have, let me switch, I may not have my resistors taped with a little label at the bottom telling you what they are. I might have a bunch of loose ones like this. And I just can't remember what the bands mean. So how do I figure out what size resistor that is? Well, you're going to grab one of Mr. Brower's multimeters here, and we're going to turn it on to the ohms. I've got it set on ohms right here. And then I'm going to grab this resistor and pinch it. Take the probes and pinch each side of the resistor. While I'm doing that, the value is actually, I can see it. So let me see if I can pinch this resistor with one hand. There we go. So I'm pinching it with one hand, and I'm going to show you what I see on the screen. So this one says 220 ohms. So that's what I need. Alright, so I've got that resistor in my hand. I'm going to just stick it in my breadboard so I don't lose it for right now. And then I'll turn that back off and set it aside. Okay, let's go back to the build here. I'm going to put my LED there, and I'm going to put my resistor right there. Nothing magical about this location. I could put it, hopefully by now you realize I could put it over here, I could put it up here. Oop, make sure it's in the holes. I'm just selecting wherever I started this build at in the rows that the LED is in. Then I've got to follow along and make sure the resistor is in the right spot. So here I've got options where I want to put it. I can just put on the canvas anywhere. Now I've got to make sure I put this thing in the same row so that my current will flow through my resistor and then through the LED here. Alright, now I just got a couple wires. So the build on this one is pretty easy, and we're going to take a wire from our cathode side of our LED and run it into ground. And at this point, we'd grab another wire and we put it into one of these pins, one of our digital pins. But it's a good practice to make sure your circuit works. So if we run this into 5 volts instead, and let's try that out. I'll put it in there, and then you'll need to plug your Arduino into the computer. I think it'll do it automatically when on this simulation, when I hit start. Yes, it plugs it into computer, and the LED goes on. So I know my circuit is doing well. If I'm just curious to know what would happen if I messed up somewhere. Let's say I had this resistor over 1. What would it do if I try to start the simulation? Would it give me an error or anything? Well, it doesn't know what I'm trying to accomplish, so I guess it wouldn't give me an error. It just wouldn't go on, or my LED doesn't go on, doesn't light up. Alright, so let's fix this. Let's move this over. Try it again. Notice each time I'm being plugged into the computer there because I need to draw some power from it. I'm not uploading a program, I just need some power to run my LED. So that looks good. Now, I don't want to leave it in the 5 volts. I need to get it out of there, and let's pick a pin. Doesn't matter other than being a digital pin. Let's do lucky number 8 here. There is a difference between some of these digital pins. Some of them have those squiggly lines, like 10, 9, and 11 have those, and 8, 12, and 13 don't. But we'll show you what the difference between those two are in a later video. All right, so everything looks pretty good. So now we're going to go and see if we can write some code and show you the new stuff I wanted to show you. I need to build mine just really quick here. I'm going to switch to this. I'm actually going to use my battery and just plug that in to my Arduino, and the LED comes on. It's hard to tell whether it's coming on or not, but it's on, nice and green. So my circuit looks pretty good. I'll unplug my battery, switch my pin. What did I say I wanted to go to? Pin 8. Okay, so we're going to go switch mine around to pin 8. All right, let's go back to this. I need to open up an IDE, and I've got a few choices. The one I opened up, this is kind of interesting, the one I used for the Microsoft Store, if you watched my other videos, you will have heard me whine about this Arduino IDE, which I got from the Arduino official webpage. I don't know why, it's just really slow. And then I did the Microsoft Store, and this one seems to be a lot faster. So I'm even using different ones every time. Switching things around. So, with my luck, it'll be slow again, but we'll see. All right, so this is what we start off with, and you're not going to be able to see that very well probably. There is a way besides Control Plus for some reason, which doesn't seem to work very well. Actually, let me try Control Plus. No, not very happy. I don't know why. I wanted to increase the font size, do this manually. Let's do a few more. It says do Control Plus, but yeah, I do that and it doesn't work. Maybe if I did the other plus. Let's try that. Just for giggles. Hey, it wants 1 plus, but the other one on the far right side of the keyboard doesn't work. That's fine. That should be big enough. I should just do a couple more. That looks pretty good. Douse that out. Oh, it's unhappy with me. Why are you unhappy with me? Alright, so here we are with the code, and like I said, we want to make the LED act like an SOS distress signal. So we're going to set up a little basic structure, and then I'm going to introduce what I wanted to teach you today. So the basic structure would be our pin mode, and we use pin 8, and it's going to be an output because we're sending information out of the pin, out of the Arduino. And when I say pin, of course I'm referring to where I put my wires into the Arduino. I gotta let know information's coming out. So what information is going to be coming out? We're going to be sending to pin 8 a high, which is a 5 volt. So that's going to turn it on. I just sent this to the if I just download this to my Arduino, it would just turn on and stay on. So let's at least get it go on and off for a second here. And tell pin 8 what do you want it to do now? I want it to go low, and do that for 1 second. Alright, so that looks pretty good. If I maybe a good troubleshooting practice would be just write some pieces of your code, some structure, download this, test it, see if it works. Let's do good practice here. If you get better, you may decide, well, I don't need to write that much down. That looks pretty good. I'm not going to worry about that. As a beginner, you're going to maybe like, well, that's a lot of code there. Maybe let's see if that works. So I'm going to be plugging down here where you can't see. I'm going to plug mine in and get the computer here, turn it on. Before I turn it on, I got to make sure that it has selected the right board and the right port, which it did automatically. So that's pretty cool. And let's upload it. Upload it, and it wants me to save it. I don't really care. It looks like it's, that's not even worried about that, where it's going. Let's just hope it's super fast here. Usually takes a moment. The last time a moment was more like 2 minutes. Usually it's done within 20 seconds, 30 seconds. So this looks like the 20-second, 30-second success that I want to see. All right, I'm going to flip to here to show you what I've got. I've got my LED flashing on and off, so it looks good. So I've got a good circuit. I've got a good chunk of code right here. That seems to be let's go back to that so you can see it. I've got a good chunk of code. It seems to be operating properly. Now I can proceed with today's lesson, which is comments. Sometimes when you're writing your code, you want to put some comments down that the code won't see. That reminds you or someone else looking at the code, what's happening, what's this about. So one way to do comments are these two forward dash. I'm not sure whether they're called forward dash lines. Forward slash. I'm going to call them a forward slash. You can tell me later if I'm right or wrong. So I put those down, and then I can write some comment. This will this will send 5 volts to or out of pin 8. And I can put them anywhere I want, and I can put them on this side if I want. And now you'll notice that the color changed, so when I run this program, it won't even see that line anymore. And that's helpful for troubleshooting. If you're like trying to figure out what is the problem, you can put a comment in there and get rid of that line and see what effect it might has. Which is a really cool thing about coding is you can do all these little experiments to figure out what's happening. Why is this not behaving this way? Why am I not getting the results I'm after? And you run little tiny experiments to figure it out. Alright, so that seems to be working. Now there are a couple of different ways to write comments. I'm going to share those with you as well, so we can write them this way. And let's say I wanted to get rid of a big chunk of code to hide it, not get rid of it. I can always delete stuff. I can use this, what I call forward slash, and a little asterisk. Where are you at? There you are. And notice everything below that is gone. Gone in terms of what the computer will see. So maybe I only wanted to get rid of those 4 lines. I wanted to remove them so I could work on something else or test something. I do just the opposite. And now you'll notice this bracket has come back. It sees that again. So everything in between from here to here is no longer visible. So that's a nice way to remove things from the computer eye. You wouldn't ever probably write a comment. I've seen some people at the very beginning of the program, they'll do something like this. They'll write a bunch of comments, comment, just a bunch of stuff up here, lines and lines of stuff, and they kind of tell you about the code and what's happening. This is just a bunch of gibberish I threw in here before it starts. So if you're a coder, if you want to see what this does, you can read the comments above explaining what it does. And usually down below, I usually just see these kind of comments right here. So those are available. Please use them a lot. As you get into coding a little more, some things you won't need to write comments about. Like digital write, you'll use that so much, you're like, I don't need to write a comment about that. I already know what that does. One more thing, if you're using this IDE, that's kind of useful. If you highlight a chunk of code and you come up here to edit and you hit comment, uncomment, it'll immediately put those slashes there, and the computer won't see that part. And then I can undo that by clicking on it again. So that's a fast way to take out a section. And when I'm in class, you'll see me use these techniques all the time, trying to figure out what is wrong with your code. I have to take chunks out and isolate where the problem is. So start using those comments. Okay, so that was half of what I wanted to explain to you. I wanted to show you how data types work, and they'll be very useful for this code, as you'll see in a minute. We have an 8 here, a bunch of 8s down here, and 1,000 here and 1,000 there. We want to be able to substitute a variable in for all those numbers. So we're going to do that up here at the top. We're going to set up some variables and substitute those in for those numbers. So we have to tell the computer what kind of variable we're using. A variable could represent a word. A variable could represent an integer, a whole number, a decimal number, a certain size number. If you don't want to use as much memory, so there's lots of different data types. Our numbers here, they're all integers. So we're going to use an integer data type, which is int. So we're telling our program that this next thing that I type in, its value is going to be an integer. So I want I'm going to declare right off the bat. I want to, instead of using 8s down here, I'm going to write pin. I'm going to substitute that for pin, and I'm going to assign it. I don't actually have to assign it. I could just say it's going to be an integer, but for this example, I want to assign it the value of 8. And of course, 8 will be the pin that we stuck our wire in to complete our circuit. So down here, I can substitute pin. And pin is probably not, well, for our program, it would be great. We'll find out that a little more description will be helpful. So I've substituted pin in wherever I saw an 8. That looks great. I use a semicolon at the end. Everything in setup is in brackets. Everything in void loop, I got an open and closing bracket. I would also like to have a function for my delays. And I'm going to think ahead just a little bit here. Actually, we're doing our S.O.S. So this little part of our code is going to turn the LED on and off. I would like it to be, we're going to start off making the dot, which is going to be a tiny amount of time. So I'm going to make this part of the first dot. So instead of 1,000, I'm going to call this delay time dot. It's probably a mouthful for a variable, but I'm going to actually do that. And then I'm going to declare a variable, an integer. Use the exact same dot. So now I can set up a time. I think I want it to be a short amount of time for a dot. So right now it's going to be 500. And then that's while it's on. And then while it's off, I can also do a delay time. So I call this delay time dot. Maybe I should do delay time dot. This is getting a little silly, the size of this variable name. But I think it's okay since we're just introducing this idea. Delay time dot. This is for when it's high. So I'm just going to say high. And then this one we're going to do low. All right, there's no way we will not remember what this variable is all about. Okay, so notice as well when I start typing this value in, it changes color because this is already a predefined word. It already knows, it already assumes, you're thinking, hey, you want me to do delay here? And if I just leave that, it's going to get confused and it'll give you an error. So I don't want to just leave that. I don't want my variable to be called something that I wouldn't call it digital right. I wouldn't want to call it pin mode. I got to give it a unique name. And we've already selected delay time dot LOW, low. I'm not sure how long to make that. Let's say 100 or 1/10 of a second. All right, so now I can control, get a little space here. Now I can control how long the dot is on and how long the dot is off. Okay, and then I need 3 of those, right? So now we're going to speed things up tremendously by doing a little copy and paste. You're probably wondering, man, it's going to take forever doing all these. All right, those are first my 3 dots. And the cool thing about using these variables is when I run this, I can quickly change the delay time for everything by just changing these numbers up here. I can control my program from up here. The variables I've selected and defined, I can now control what's going to happen down here. If I didn't do this, I kept the numbers in here, then I'd have to manually go through and change them, every single one. So that's one nice thing about taking the time to do this step. Okay, so I could pause here and figure out if I'm satisfied with those dots. Maybe I'll do that, do good practice here. Let's upload this. I'm already hooked up to the computer. And let's see if we get a satisfactory, whoop, we got an error. Errors are cool because there are teachable moments here. Delay time dot, I have delay time dot high. Well, that is a bummer because now I have to go back and fix all these. I talked about it, but then I didn't go in and put it in. All right, let's try it again. I had to make sure it was looking at delay time dot, and it was saying, what does that mean? I don't know what that word is. I haven't defined it up here. I haven't said it was an integer with this value. All right, so that looks good. I'm looking down at my switch here, the camera only, and my light is flashing. I don't know if that's a good dot. Frequency or rate. I think seems all right. We'll go with it. Maybe a little faster, maybe a little slower. I'm not sure. Okay, so we're almost done here. We got to do the dashes. So I'm just going to grab one more of these because I don't want to type when I don't have to. This is going to be my dashes and not my dots. So I'm going to have 2 more variables, delay time dash high. You want this to be longer, so we're going to go full second, and then declare this new variable as an integer as well. I could call it whatever I want. I could call it a ham sandwich if I want, but that's not going to be very useful later on when I'm trying to figure out what it was I was trying to accomplish. And let's stick with the 100. Okay, so delay time dot dash high. So I got to go back here and modify this. Let's do a little surgery here. Dash, and change that to dash. That looks pretty good. Okay, we need to do that 3 times. Well, 2 more times. We did this once. Control V, Control V. A little space in there would be helpful. All right, so now it's going to get a little confusing. I could even use a comment here if I wanted to, maybe like right here, just visually so I can, oop, man, I'm being really silly here. I apologize. I forgot to switch back to this. I don't know how long would it have been switched? I'm not sure. No. I can't remember how much I showed you without switching back. I think what I did is let me just show you, scan down a little bit, show you what I've got so far. I made my first 3 dots right here. And then down here I've got my next 3 dashes. They're just repeats of each other. And then I've declared all my variables up here. Remember not to be more careful about that in future videos. And then I was looking here and seeing visually that it's kind of hard to tell when I'm doing a dot. Here's my final dot. And then I'm going to do the same thing down here at this comment. Final dash. I think we'll be okay. So if I recall, I switched screens when we were testing this bit of code to see if it was working. And then I didn't switch back. So I don't think we're fatal. I think we'll continue on. But I do need to have one more set of dots. Let's add that as well. Control copy, Control V. Let's give it a little look here. I got my 3 dots. It'll go on and off, on, off, on, off. And then it'll go on longer for these 3 because they're the dashes. And then I've got, did I miscount? 3 there and 3 there, 3 dots, which I can control everything from up here, which is really nice. So if I don't like how long that dash was, I can come down here and come up here and change the value. Let's give it a try. I'm going to upload that. Get so focused on my code I don't look on my other screen to see what you're actually seeing. Alright, that was quick. I'm pleased with that. Let's take, do I even dare switch to this? Probably should get in the habit of just doing this, to be honest with you, and then I won't, worst case scenario, just have a large version of me up there. Alright, although it's a little harder to see that I'm getting my dashes and dots. There's my dots. There's my long dashes. So it looks pretty good. Alright. So, a little recap. The point of this was, maybe shrink it back down, to show you how to set up some variables. Got to define them. What kind of data type, what kind of variables is going to be. We have to tell the computer that. Inserting that into our code. Some comments. And that is it. So we are ready to move on to the next challenge.